Hi everyone. Our names are Aditya, Singh, Arjun, Kasturi, Arnav, Bhatia, and Sounak, Ghosh. Our project is the library management system. Next slide, please. The purpose of this system is a database-driven application that streamlines day-to-day library operations. And the primary goals of these are it's an efficient resource management, seamless reader interaction, automated tracking for borrowing and returns, and comprehensive report and analytics. Together, these goals will help reduce friction for librarians, make discovery easier for readers, and give library clear data to improve their services. Aditya, it's your turn.
Thanks, Arjun. I'm Aditya, and I'll quickly walk you through the core structure of our database. So on this slide, you can see our three foundation entities. First, the books, which are the heart of the library, each identified by a unique ISBN. Next are the readers, our members, each with a unique user ID. And finally, the staff, who manage the system and are tracked by a staff ID. These three are the who, what, and how of our system. Also, to support them, we have four key components. The publisher entity simply tracks who publishes each book. Our authentication system provides secure, password-protected logins for the staff. And the reports entity allows staff to monitor library activity. And most importantly, the borrowing returning component is the transaction system that links readers to books and tracks all the due dates. That covers the what of our database. Now I'll pass to Shaunak.
Let's examine how entities connect and interact through their relationships. Our staff entity connects to multiple entities. They have one-to-many relationship with reports. Each staff can generate multiple reports. They link one-to-one with authentication for secure login. Staff also maintain a one-to-many relationship with books for catalog management and a many-to-many operational relationship with readers. A reader entity forms the core of our borrowing system. Readers have a one-to-many relationship with borrowing transactions. One reader can borrow multiple books over time. Similarly, each book entity can appear in many transactions, creating another one-to-many relationship. Our publisher entity maintains a one-to-many relationship with books. One publisher produces multiple books, but each book has exactly one publisher. The authentication entity provides one-to-many mapping with staff for security. These cardinalities ensure proper data flow. Next slide, please. Database design and constraints. Each entity has strict constraints. Books use ISBN as a primary key. Readers use auto-incremented user ID with unique email constraints. Staff entities have unique staff ID, and publisher maintain unique IDs and names. We handle complex attributes carefully. The reader entity's multi-valued phone attribute becomes a separate reader phones table linked through user ID as a foreign key. The composite name attribute in reader splits into first name and last name fields. For relationship implementation, foreign keys enforce our cardinalities. Book reference, publisher ID, reports reference both staff ID and user ID, and the borrowing relationship tables uses both user ID and ISBN as foreign keys. This constraints guarantee referential integrity. You can assign a book to a non-existent publisher or create a transaction for a non-existent reader. This results in a robust system where entities maintain their relationships reliably. Heading off to Arnav.
Yeah, thank you, Sounak. So I think Sounak and Aditya have already done a wonderful job explaining the entities and all the relationships, but I'll just go over the diagram very quickly. So this is our ER diagram for the library management system. So we have modeled 7 entities: book, reader, staff, publisher, authentication, borrowing, returning, and reports. So starting with book, the key is ISBN. So we store the title, category, edition, price, and the authentication number for field for each author info. Each book is linked to exactly one publisher, and each book is maintained by one staff member. For publisher, we have publisher ID, name, and year of publication. The cardinality is publisher has a one-to-many relationship with book. A publisher can have many books, but each book can only have one publisher. So for staff has a staff ID and name. Staff accounts authenticate through the authentication entity with login ID and password. The authentication has a one-to-many relationship with staff. Each staff has exactly one login, and one login can be associated with multiple staff in our simplified model. So together, these entities and all the other relationships cover authentication, catalog maintenance, reservations, and loans, and member tracking and reporting, aligning the data model directly with how our library operates. So can I have the next slide, please, Aditya? Yeah, so this is our implementation architecture. We are building a dynamic web app with a responsive UI so staff and readers can access it from browser. So on the front end, we will be using HTML, CSS, JavaScript. We handle navigation, search, borrowing history, and account management with a clean, responsive layout. Our database is PostgreSQL, structured directly from the ER diagram to store books, readers, transactions, and reports with constraints for data integrity. End-to-end user action would be from AJAX to PHP to SQL to JSON response, and then an instant UI update. That's it. So that's it from our side. Thank you for listening.